The BP motion controller is already using the animation blueprint that we are adding onto. Remember that the controller changes the pose of the hand when we press the grip or get close to a pick-upable actor. Let's expand on this setup and tell the animation blueprint that we are holding a dart, so set that holding dart bool variable to true, so it can adjust the blend spaces accordingly. Before we get started though, open up the BP motion controller in the VR pawn folder. We just want to be sure that the hand mesh is using our animation blueprint. So on the right side in anim class, make sure this is set to right hand anim BP darts and compile this. Create a new custom event named getReferenceToAnimBP. Disconnect the cast to right hand animBP darts and move it to the new event. Promote the returned value to a variable named animBP darts. Call this before the eController hand logic is called. Plug in the variable to replace the disconnected cast node on the setGripState node. Create another custom event named updateHandAnimation. We're going to move this logic out of the way so we can keep this blueprint nice and clean. Call the function from the then 0 and move the hand animation logic away to the right. After update hand animation, get a reference to the attached actor variable and cast it to BP dart. On cast failed, plug into the old logic, and on true, create a branch with the condition of holding dart. The branch is here to ask if we are already holding the dart, and if so, send the data to the animation blueprint, and if not, update the variables here and in the animation blueprint to true. So from false, we'll set the value of holding to true and get a reference to the animBP darts variable. We'll use this to set holding darts to true as well. At the end of setGripState, add a branch checking the value of holding dart. On true, set holding dart here and in the animation blueprint to false. We need to create a function that will tell us where the dart is that we are holding so we can tell the animBP where in the blend space the animation should be. Create a function named determineLocationOfDartHold with two outputs. Both float variables, name them up, down, and the other back, front. Just going to place it in an animation category so to stay organized, and I'll compile this. Return to the event graph where we are setting holding dart to true and drag out a copy of this new function. Plug it into both the true of the branch and after we set the holding dart variables to true. Also, drag out a reference to the animBP darts and set up, down, and back, front from the outputs of this function. And again, I'll compile. Before we build the logic inside our new function, we need to make a change to our motion controller pawn. Because we are building the pawns with inheritance, we don't want this logic to only work for this specific motion controller pawn, but any pawn we may make in the future. Open motion controller pawn and select both the VR origin and the camera and copy them. Now open our parent and paste them into the Components tab. And compile. Return to motion controller pawn darts. Notice that the VR origin and camera is now inherited, and the ones that were here have an _0 appended. This is because the parent took priority of what the child had. We need to replace any reference from the old component to the new ones. Right-click the VR origin component and select Find References. Double-click at the results at the bottom one at a time and drag the new component on top of the old one, and it will automatically replace it. I'm just going to go through and quickly do this. So I'm dragging the new VR origin over the old one, and it quickly replaces it. And do the same for a camera 0. Find references. Camera. And because of these are copies, these are direct copies, they contain all the same logic we had previously set to the original VR origin camera. Things like the post-process settings. Compile this, and now we can freely delete VR origin and camera with no issues. Return to the determine location of dart hold function inside of BP motion controller. From the return mode, promote both outputs to their own local variables and name them the same as the outputs, adding _local to the end. So this one will be up, down, local. And this is back, front, local. Starting with logic that will be used by both variables, we will calculate this by determining their relative location from a point left or right from our head, depending on which hand we're using. First, we need to identify this point for use. Right-click and search for Get Player Pawn. From the return value, cast to BPP pawn darts and right-click the cast node, and at the bottom of the context menu, select Convert to Pure Cast. This is why we moved the VR origin and camera to the parent pawn, so any pawn that is inheriting from BPP pawn darts will allow this cast to succeed. From As BPP pawn darts, get a reference to the camera, and then from the camera, search for Get World Transform. Split the transform struct. From rotation, search for Get Right Vector and multiply this by a float. Right-click and search for Select Float. In A, type 20, and in B, type -20. Drag in a reference to the hand variable, and drag off of it and create an equals enum and plug this into pick A. Add the result of this to the world location of the camera. Now we found our point in world space and can reference it for use in our two variables. Let's work on up, down, local first. From the sum node, search for break vector. We only want to use the z value from this point. Drag in the reference to our motion controller and get its world location. Right-click the return value and break the struct. Subtract the z by the z of our point. Drag the result into a new map range clamped node. We'll dive into this in a bit. Set in range A to -50 and in range B to -10. Outrange A to 0 and outrange B to 1. This node will be expecting a value between and including -50 to -10. These values are a bit arbitrary. They are rough values of how high or low our hands can be from our world point. It then takes this value and compresses it to somewhere between 0 and 1. -50 will be made into 0 and -10 into 1, and everything in between will fall somewhere between 0 and 1. From this value, we're going to set our up, down, local variable. Now let's do the back, front, local. Plug the world point into a new distance 2D vector node. Again, bring in a reference to the motion controller and get the world location. Plug that result into V2. From the return value, create a new mapped range clamped. This time, we'll be searching for a value between 20 and 60 and converting that to 0 and 1. The result of this will set back front local. Compile the blueprint. If we were to press play now, we would see that all our logic in our blueprint is working, but the dart is not in the correct spot. This is because we are telling it to attach to our motion controller and not directly to our hand. Let's fix this. Back in BP Motion Controller, open the grab actor function. At the end, we are sending our motion controller as the component to attach to. It needs to be our hand mesh, as that is the skeleton that has the dart's socket. Make sure this is also done in the release actor function. And compile. After you've changed the references from motion controller to our hand mesh, open up BP Dart. In the attach to component node, set the socket name to Dart, as that's what we're going to be providing the pickup function. In BP Motion Controller, make sure our hand mesh is using both our right hand anim BP darts as well as the mannequin hand right that is in our darts folder. And compile it. Making sure that Dart Hero is at a location of -30, because that is how it conformed to the Dart controller when we set that. Open a mannequin hand right, and you'll see that this is where our Dart socket is. So we also need to when we attach to component, we need to not keep the world, we need to snap to target. So change location rule and rotation rule to snap to target. And now compile this. So now press play in VR, and we can immediately notice a difference. Now when I pick up the dart, I'm holding the dart properly. When I pull it close to my face, you notice that the hand is blending as if a more steady aiming posture. When I go further away, it is now a much looser about to throw posture. So the blend spaces are working. Now that we have the working dart and the animated hands, we'll now start to build the last object for the dart game, our dartboard.